So far, we have worked with this one type of linear equation, and that is y equals mx plus b, where our m is the slope and our b is defined as the y-intercept. So this is super useful, but you'll also notice that we've got different forms of linear equations. Today, we're going to introduce the standard form of a line, ax plus by equals c. So typically when you see an equation in that form, your a, b, and c values are integers. So I'll give you an example of what one looks like. This is an example of a line that's in standard form. And if we were to see that, we would say in that example, a is 2, b is 5, and c is 7. So the useful thing about standard forms is that we can oftentimes graph them in a different way. And we end up graphing lines that are in standard form by using the x and y intercepts. First, let's define these terms. We'll start with the x-intercept. By definition, the x-intercept is where your graph intersects with the x-axis. So in this example, where does my graph cross the x-axis? At -7. So we would say, for this example, my x-intercept is -7. One thing that is noteworthy is for the x-intercept, your y is always 0. We could also write that ordered as an ordered pair, -7, 0. So your x-intercept is where your graph intersects the x-axis. Your y-intercept, we've already talked about a little bit, and that's when it was in our mx plus b form. Y-intercept is where our graph crosses the y-axis. So if we looked at this line, we would say that the y-intercept in this example is 4. And again, what is important about the y-intercept, your x is always 0. So we could write that as an ordered pair, and that would be 0, 4. So your x-intercept, what is important, your y is always 0. Whereas for your y-intercept, your x is always 0. So the next couple of examples, we are going to find the x and y-intercept, and then we're going to use those intercepts to graph equations of lines. So let's look at this one example where we're asked to find the x and y-intercept for each problem. Now, what I like to do is when I think, if I'm looking for the x-intercept, I know that my y will always be 0. So what I do is I take that equation and I make the y disappear. Because if it's my x-intercept, that y would be 0, and that would go away. So I'm looking at 4x equals 12. And then I solve for x. And I get that x is 3. Now, remember that we want to write this as an ordered pair. So I could write that as 3, 0. So if I wanted to do that same concept and look for my y-intercept, that's where my x is 0. So I can then just ignore that x term, because that's going to cancel out, and I'm left with -3y equals 12. And then when I have that, I can just solve for my y. And I get that my y-intercept is -4. And I can write that as an ordered pair. And that would be 0, -4. So if we looked at question 2, we can still answer the question of finding the x and y-intercept by remembering that for the x-intercept, your y is 0. In this example, we would plug in 0 for y and solve for x. So we want to get x by itself. So we're going to move that 2 over, leaving us with 2 equals 3/2, or 2 equals 3x. And then We divide by 3 to get x by itself. And we have that x is 2/3. And remember, I can write that as an ordered pair. 2/3, 0. For my y-intercept, I'm going to set my x equal to 0. And so that term goes away, leaving us only with y equals -2. We also knew that because this is in our mx plus b form. Y equals -2, and we can write that as an ordered pair. It's worth noting that if you look at this pink line, that's the horizontal line y equals 3, that not every line is going to have an x-intercept. You'll see here, y equals 3 is a horizontal line, and it's never actually going to cross the x-axis. So this would have a y-intercept of 3, but no x-intercept. Conversely, this blue line, the vertical line x equals 4, we can clearly see has an x-intercept at x equals 4, but this will never cross the y-axis, so it won't have a y-intercept. Here, we still want to find our graph, and we're going to plug in our, or find the x and y intercepts. So we'll start first with the x-intercept. Remember, y is 0, so we make that term go away, and that gives us 4x equals -20. And once we have that, we can solve for x. We divide both sides by 4, and we get that x is -5, which we can write as the ordered pair -5, 0. And there's our point. So we've got 1 point down, 1.1 to go. So then we find the y-intercept, and that means we're going to plug in 0 for x. So that leaves us with 5y equals -20. And then we get our y by itself. So we divide by 5, giving us that y is -4. And we can write that as the ordered pair 0, -4. And then I can plot that on my graph and connect those 2 points. And there's my line. Here's a question in Delta Math that's asking us to use technology to find the points and to graph that line. And so what our objective is for these problems is we're going to use the x and y intercepts to find those, and those are the 2 points that we're going to plot. So you see I've got the equation written here, and so we're going to find the x and y intercepts. I'll start with the x. Remember, for the x-intercept, your y is 0. So we're going to hide that y term, and we have 6x equals -6. So then we divide both sides by 6, and we know that x equals -1 is a point. And we write that just like that, -1, 0. So we're going to plot that on our graph. Next, we find the y-intercept. So that's where we take x, and we set it equal to 0. And that gives us positive 2y equals -6. So then we're going to divide both sides by 2, and we get y equals -3. And remember, we can write that as 0, -3. So the next thing we're going to do is go back to Delta Math and plot the point -1, 0, and 0, -3. So the first thing we'll do is plot -1, 0. The next point is 0, -3. So I plot that. I'm finished. Then I've got my and that should be our line.